I will be starting with section 2.1, and this is on fractions. Okay. You guys have heard about the word fraction?
I'll take this one.
Yeah, you can take this one. Okay, so how many of you have seen the word fractions before? Fractions, yeah. Okay. So let me give you a definition of this. So fraction of whole numbers, okay? So a fraction is any number that can be put in the form A over B, or sometimes people would like to write this way, A slash B, where B cannot be 0. Okay, so a fraction is any number that can be written as the ratio of two whole numbers, okay, where A and B are two whole numbers. So in this notation, so in this notation, if I write A over B, so we call B what? Anyone knows what is the term for B? It's called denominator, right? It's called the denominator. And what's the name for the one above? It's called the numerator. Okay, so if I have a fraction, the number on top is called the numerator, the number on the bottom is called the denominator. So what are some examples of this type of numbers? Well, the number half, the number 3/4, the number 7/8, the number 9/5. These are all fractions. Now, okay, there are two types of fractions, okay? We call them either the proper fractions. The proper fractions are the fractions where the denominator is bigger than the numerator, okay? So here, the denominator is larger than the numerator. Oops. And so what are the examples? Well, 1/2, 3/4, 2/7, 100 over 107. These are all proper fractions. So the word proper fractions refers to the fractions where the denominator is larger than the numerator. And so you can imagine that there are improper fractions. So we have improper fractions. So what's the difference? It's the opposite, yep. So in this case, the denominator is less than the numerator. What's that? So in the first one, denominator is larger. In the second one, the denominator is smaller than the numerator. So this symbol that I have here, that means greater than, larger than. This symbol, the opposite symbol, that's the less than or smaller than. Okay? Everybody's okay with that? Yeah. All right, so denominator is less than numerator. So examples of this type of fractions would be what? 7/4. If I have the number 2, that's the same as 2 divided by 1, right? The number 2 is the same as 2 over 1. And then you can have, say, 4/3, and so on. So these are the improper fractions. Now, why do we use fractions? Because they are useful, right? You know, how did we get into, why did we want to use fractions? Well, because there was a need for using fractions, okay? And the need grew out of human need a long time ago. For example, you can imagine that in the ancient cities, when they were doing trades and all, people, they didn't have any currency, so what were they trading? Well, they were trading cows for chickens or something else, right? So you usually go to the market and you buy 50 chickens for 1 cow, okay? But one day you decided, well, just buying chickens isn't good enough. I need to buy something else too. So I'm going to buy 25 chickens, maybe 25 fishes. But I have only 1 cow, so what should I do? Well, maybe go to the market and argue that, okay, I'm going to give you only half of the cow, right? And then the other half I'm going to use for the fishes. So my point is, these fractions came out from very simple human needs, okay? And so the number 1/4, for example, what is the interpretation of that? It means that one interpretation is that I can divide one whole object into 4 equal parts and take 1 part, right? Yeah. So one interpretation of this is that you take one part of 4 equal parts of one whole object. Yep. Yeah, we're going to talk about the percentages and all later. So one whole object. How about if I have the number 3/4? What is the interpretation of that number? Well, you take 3 parts, right? You take 3 parts of of the 4 equal parts of one whole object. How about though if I have the improper fractions, right? So for example, if I have 7/4, what would be the interpretation of that?
Take 4 and we need 3.
Yeah. So the interpretation of 7/4 is that I can write 7 as 4 plus 3, right? So 7 is the same as 4 plus 3 divided by 4. So that means if I divide, and so I can, we haven't talked about adding fractions yet, but one thing that you learn that this number is the same as later is the same as 1 plus 3/4, okay? So it's one whole object plus 3 parts of 4 equal parts, okay? So that's how we can interpret these fractions. Okay. Yeah. The last one? Yeah, the last one we are going to talk about adding fractions later. So don't worry about how I'm going from here to here. But for now, just believe that 7/4 is the same as 1 plus 3/4. And so it's one whole object plus 3 parts of 4 equal parts of an object. In a bit today, I'm going to talk about adding fractions, and that will show you how this. So this is basically 4 divided by 4 plus 3 divided by 4. Okay? So 4 divided by 4 is 1 plus 3 divided by 4. Okay? All right. So let's let me look at another example here. This is the example where I have, let's say I have the number 4 divided by 12. Okay. This number 4 divided by 12 is the same as 2 divided by 6. Okay, and that's also the same as 1/3, right? So if you divide an object into 12 parts and take 4 parts, it's the same as taking 1/3 of the whole object. Okay, and same goes here. If you divide it into 6 parts and take 2 parts, that's the same as taking 1 part out of 3 parts. Okay, so all these numbers they tell us the same thing. Okay, the meaning of all three fractions are the same. So they are the same numbers. Was that? Say it again. Symbolically. So what I mean here is that all three fractions are written in different ways, right? But they represent the same quantity. Okay, so these are called equivalent fractions. These are called equivalent fractions. So what are equivalent fractions? Equivalent fractions are fractions that equivalent fractions are the fractions which are the same, basically. Okay. All right. So some properties now. Let me open up another window. Some of the properties of fractions. The first property is that if I have A divided by B, that's the same fraction as AC divided by BC. Of course, I have to assume that B is not 0. C is not 0 because I cannot have 0 in the denominator, right? Can't have 0 in the denominator. So what this is saying is that A over B is the same as AC over BC. All I did is what? I multiplied the numerator and the denominator with the same number C, right? So that's allowed, and you still get the same fraction, okay? The second property is that if I have A divided by B, that's the same as A divided by